I was a little nervous thinking about giving this talk, so I was speaking with my cousin Dan, and he told me about a time when he was working with like some very big famous bands, right? And so one time in Houston, he had to go on and introduce Alice Cooper to over 50,000 people. And before he did so, he turned back to the people on backstage and was like, how can I do this? How can I go on and do this in front of all these people? And Alice Cooper turns towards him and says, when you go on stage, the lights will hit your eyes, everything will blur, and it'll look like a big bowl of oatmeal. Speak into the oatmeal. Yeah, from Alice Cooper. That's pretty cool. Okay, so I'm talking about practical packaging for machine learning solutions. And so what exactly is this? So why, if you're doing machine learning, why should you care about Python packaging tools? Well, they're very general purpose. They're not tied to any specific machine learning framework, proprietary product. They're very flexible, dependable, and extensible. You can use them for any kind of project that you do. And it makes it much easier to share your projects. Not just with the rest of the world on GitHub or Python Packaging Index, but also with clients, with engineers at your company when you're getting ready to deploy your solution. So it makes your solution much more useful or usable. So what are some targeted outcomes? So we're hoping to have at least a basic understanding of what the Python packaging tools are, and then also how we can leverage them to package up our machine learning solutions. Okay, so a few assumptions. I'm expecting that maybe you love Python, especially if you're here on a Saturday, right? Yeah, you've used pip, or at least conda, or at least some kind of package manager, because having that understanding of what a package manager is, what packages are, will be useful. Also, that it's useful to have some understanding of the issues facing machine learning and creating machine learning solutions, but that's not strictly necessary. So real quick definition. For the purposes of this talk, we're going to consider a machine learning solution to just be like a fitted model. Then it's going to include the code to fit the model, and then also the code to use the model. So like some kind of API that your end users, your end application are going to make use of. This is not including the web application, none of that. So this is how you would package it up so then you can plug it into any web application or any other use case that you might have, right? General, like just how to package up your projects. This is not a commonly covered topic in data science, unfortunately. Some of the reasons why you don't see many talks or blog posts is that it's not a super sexy subject. It's not talking about your latest TensorFlow model, right? But it is used, and it is very useful. So as a result of it's not necessarily being a commonly talked about subject for this specific use case, there aren't a lot of generally accepted best practices. So for the most part, I've tried to draw on just the general best practices from software engineering, and then my own industry experience to try and create this presentation. So here real quick, we're going to cover some of the basics of Python packaging for some of you that may not have much knowledge on it. So let's see. So real quick, a couple of definitions. So let's cover an import package is basically the directory that has your Python modules and may include another directory with Python modules in it, and so on and so forth. So that's a typical, what you might refer to as a package. A distribution package is what you do when you take all of that up and distribute it. So generally, as we all know, we tend to use these terms very loosely. We call both of these packages. And I will try to be unambiguous as much as possible, but it's easy to slip up there. So the basic requirements. So here's what just a basic package directory will look like, a project directory will look like. You don't strictly have to have a license, but especially if you're distributing it on, let's say, the Python packaging index, it's a good idea. If you don't have a license, people can't really use your code. And also it's the case that you want to at least have maybe like a MIT license if you're really open about sharing, because that at least protects you from liability if your code breaks someone's stuff. It's also a really good idea to have a README. That gives very important information about how to install your project and other kinds of useful information. Now, some required parts are, of course, the package directory, where your modules will go, because otherwise, why are we distributing this? And then also, for our purposes, the data directory, in which we will, depending on our use case, we'll place our model file. And then also another required part, if you're using setup tools, is the setup.py file. So the setup.py file is going to include the setup function, which again, you will import from setup tools, and you will pass your configuration parameters to this function. So this will include things like the name of your project, the version number, which Python packages in that directory are you wanting to include in the distribution package? Which version of Python are you covering? And then also dependencies. And then again, an important thing for us is the package data parameter, in which we can list the data files in our project directory that we want to include in the end distribution package. It is important to note that if you're uploading to, let's say, the Python packaging index, you are going to need additional parameters. Okay, so real quick note, source distribution. So for our purposes, because for the most part for these kind of projects, we're writing pure Python. So a source distribution will be good enough. What is a source distribution? It is basically a distribution format in which nothing is being built ahead of time. So let's say you were to include some custom C code and you needed some C extensions, right? None of that would be compiled ahead of time. It would be sent as is. It's also the case that if you're just doing pure Python, no metadata files necessary for the installation are going to be built ahead of time. They'll be built when it's installed. Another option would be wheels. You can look more into that. Yeah. So for more detailed sort of step-by-step how-to on that, I've written a companion blog post to this talk, and there's a link to the specific section on source distributions. I'll show this link again. Okay, so distributing it, again, depending on your use case, maybe you're working with a client and it's just a couple of people and you don't have the infrastructure to distribute it, but it is the case that you want to keep it private, you can just email it. That's okay, don't overthink it. It is nice to have, do something more, professional maybe, but so another option would be to use the Python packaging index, and that's the one that we all know and love, the one that we use when we make use of pip, when we run pip install. But that is publicly available. So again, depending on your client and the company you're working for, there are options to run a private instance of the Python packaging index, and there are also other things that you can do. So again, for a deep dive and step by step sort of deep dive into all of that, I've written a companion blog post that you may look at. So here I'm going to go over some packaging schemes that you may find helpful in how you can structure your project to package it up specifically for machine learning solutions, right? So these are just loose recommendations. You should absolutely adjust them to your specific use case because as you all may know, in machine learning, there's a lot of varied things that can happen. So the simplest approach would be to just take your project, create one single distribution package with everything in it, right? This is simple because you just place your model, the API code, everything in this one package. Here's an example of what the project directory might look like. Again, very simple, just the package directory with your code in it and a set file. Again, it's simple, that's very nice. But some cons. Every single time we package this up, we have to redistribute everything all together. And that may not be a good idea depending on maybe how big your model file is. It's also the case that everything is being versioned, is running under the same version. So maybe you've left your model file alone, but you've updated your API. If under this scheme, you're gonna have to do all that under one version and distribute it all together. So a solution to that is to split it up. So a simple approach would be to split out the code that you use to fit the model into one package, the model into one package, and the API to actually make use of the model in one package. Right? Yeah, and so the model package will include the model file, or at least some sort of reference to the model file if you're hosting it elsewhere, because maybe it's really large. And it should be just enough code to load it, and that's it. The model API package, this will be what your end user, your end application is actually going to interact with, right? This will include everything from the data preprocessing code that you want to apply to the data when you're doing some text analytics, and you want to tokenize some text first before you push it into your model to maybe get a prediction. All the code to orchestrate all these steps. So maybe some input and output validation. That's where all this would go. So why would we do this? What do we get from it? Because it's definitely adding a little more complexity, right? So what do we get from it? Well, we can deploy these things separately. And why is that useful? So let's imagine a scenario in which maybe it's not so uncommon, especially if you're doing natural language processing, that your model file can get pretty large. So let's say maybe you have like a 3 gigabyte model file, and you make one small bug fix to your API. Maybe somewhere in your API code, you left out a parentheses. And so now, if you have all that packaged together, because of one byte, you're having to redistribute everything. You're having to repackage up your 3 gig model file, re-upload it to your package repository, have it stored again on your package repository, and then have all of your users re-download it all over again because of one small bug. That sucks. So here's a quick example of project structure in which you have your main project directory and then 3 sub-project directories in which you'll have your 3 different distribution packages. Some cons of this. It's definitely getting more complex. We'll have to ship at least 2 packages, build and ship at least 2 packages. So another solution, if we have more than one model for our solution, is to just have a variable number of packages, right? And so what this means is that, so if we have multiple models, all of those should ideally go in their own package. And then, of course, all the code to fit those individual models should also go in their individual packages. But we should still only have one API package. Because if you have more than one API package, you should consider splitting it off into a separate project. So an example of this. So let's say, a real sort of classic example would maybe be like, classifying email as spam or not spam. And maybe we have a setup where we first train a topic model as a dimensionality reduction step, and then feed those results into our classification model that actually classifies whether it's spam or not spam. And so what are the benefits that we get from this? So by splitting those two up into separate packages, because typically topic models, the files tend to be kind of large. And so let's say we retrain our classifier, but we don't retrain the topic model. So that means that we can distribute those separately. So if we didn't update the topic model, we don't have to distribute that again. We only have to distribute the classifier if we update it. Now, it doesn't work in reverse because, of course, if we retrain the topic model, we have to also retrain the classifier. Now, again, so the API package, that'll actually include all the code that composes those two, right? That's where that'll go. And then it also makes sense that the package that we use to fit the classifier, that'll depend upon the model file for the topic model, or the model package. Yeah. So some cons to this. It's getting even more complex. We're getting even more packages that we're having to manage. And then also, as things currently stand, we're going to have a lot of duplicate code and effort. But there are things that we can do about this. So, for the issue of duplicate code and duplicate effort, what we can do is we can, so for example, like let's say we have some pre-processing code. So it's the case that we'll want to make use of that code in the package in which we train the model, and we'll also want to make use of that code in the API package, right? Because as we're training the model, we're wanting to do some sort of transformation on the incoming data as we train it, and then also some sort of transformation on the data as we maybe make a prediction using the model. So a solution is that maybe we take that pre-processing code and split it off into its own package, right? So just some things to avoid. Avoid some bad dependency patterns such as circular dependencies. And if you have one package that depends on another one, don't have that one depend on the first one. That's a really bad thing to do. Also, some quick notes about listing version numbers. So talking about having our packages depend on our own packages within a single project, definitely list lower boundaries on the versions. Because we want to make sure that none of our users ever end up with old dependency packages, right? We don't want them to ever end up in that kind of state. But do consider being very flexible with the upper boundary. Definitely avoid pinning to specific versions if you can. And the reason why is that if you pin it to a specific version, we kind of lose a lot of the benefit of splitting these things up. Because then whenever you pin it to a specific version, all of a sudden you're having to, you're pinning it to a specific instance of that package, right? And so so if you update that package, you have to redistribute the package that depends upon it, so you have an updated version number in the requirements. So the other issue that we're dealing with is that especially now, we're ending up with a whole ton of packages. How do we manage this? So first off, for the creation part of it, where you're actually creating them, an idea would be to create basically a template directory in which you go and create a setup.py file with all of the configuration parameters that are going to be identical across the projects, and then just copy and paste where needed. And then as far as building and uploading, and this also applies to updates, is that as you finish coding and you're ready to release a specific package, just go and build it and upload it. Like, you don't have to wait until the whole entire project is done to go through all of your different packages and build and update them, build and upload them. And then as far as installation goes, one option is that we can provide our users with a requirements text, right? And some of the benefits of this is that, of course, we can list all of our dependencies. We can list their versions that we want them to install. and we can list where they should install it from, or where pip should get the package from, right? So let's say we have, for some odd reason, we have in our single project, we have packages uploaded to the public Python packaging index, a private package repository, and then maybe even GitHub, just to make things complicated. We can list all of those in the requirements text. Another option would be to, within the packages that we control, list the dependencies within our project, list the packages that they depend on within our project as dependencies in their setup.py file. And then as a result, because our end users, the application developers, they're only going to be interested in installing the API package. And so when they install that, pip is going to go grab that package. When they run pip install our API package, pip is going to go grab that package, look at its dependencies, and look at its dependencies, and so on and so forth, and just automatically download everything. So they only have to run pip install that one package. The preferred option, especially if our machine learning solution is a distribution package and not an end application, is to use the second option, to list them in setup.py. And the reason is that this allows the end application developer to pin specific versions of the packages, and also to specify where the packages are coming from. That's considered a pretty nice thing to do, is to allow the end developer who's making use of our package and then distributing it to their end users, to allow them to specify where the package is coming from. So about handling data, of course, again, because we're talking about packaging and machine learning solutions, this is a really important thing for us. So if you're looking to upload your solution to the public Python packaging index, some things to note. The default limit on package size is roughly like 600 megabytes or so. It can be increased, but on the whole, if you're pushing that limit, especially with this, you should consider hosting maybe your model file somewhere else. Okay. And then also the Git version control. Sometimes if you have really large files, I've heard people having problems with that. So consider not, if your model file is getting really, really large, consider not including it in Git version control. The training data, especially if we're talking about supplying a pre-trained model, you don't need to include the data in the package, or even let's say you're uploading it to the Python packaging index. Just include a reference to the data to allow the users to download it. There's no reason to include it. So in conclusion, I think it'd be useful if we as a community maybe discussed more just some general good best practices about how to package these solutions using, again, general tools. Not any specific frameworks, not any specific proprietary products to help us deploy our product, our machine learning solutions, but just some good general best practices. That would be nice. Thank you. Oh, and again, that's the link to the post that has a more detailed step-by-step introduction to packaging. Absolutely. Any questions? Yes.
So you talk about publishing and updating multiple packages, right?
Mm-hmm.
So how would you make some packages work together? For example, an API to use a model.
What was this?
Model again?
Yeah. So let's say you maybe retrain the model, and you want to update that for your users. So all you do is you retrain the model, repackage it, maybe upload it to the repository that you're using, and then just have your users download the update from there. Pip install whatever, the package dash update. Yeah. Yes.
I was a different means than using setup.py or generate setup.py for you. Use anything like that to make that work easier.
I don't personally. So, I mean, are we talking about solutions? So, again, the question was, there are other things out there that maybe automatically generate some of this stuff for us, or maybe make it easier? Is it the case that the things you're talking about are specific to this use case?
No.
All right. I mean, there are other, even within Python, there are other packaging formats that you can go with. But currently, this is the one that's recommended by the Python Packaging Authority, and so that's why I kind of went with it. But as far as like I think there's a project called like Cookie Cutter that attempts to, yeah, yeah. There are some things that automatically generate the structure, and if you find those useful, you can make use of them. But at least for me, like I've generally found, like it to not be that difficult or that taxing to just write this out myself. But yeah, definitely if you find something that you like, make use of it, for sure. Anything else?
Do you have any tips for outlining from the beginning, like what you would put in the setup file, right? Like for training, like what would, if you broke it into pieces, do you have an example of that?
Yeah. So the question was, can I give an example of like from the beginning, like when you're like maybe planning the project?
Right.
Yeah. How you might go ahead and outline the setup.py file. So I mean things like going ahead and specifying who the author is and stuff like that. A lot of those sort of basic things can go ahead and be done ahead of time. As far as including what kind of data include, odds are roughly what kind of model you're going to use, what kind of framework you're going to use, and what kind of files that framework tends to save the models to. And so that way you can go ahead and kind of plan ahead of time how you're going to structure that. And as far as like some of these sub packages that you might create, as far as like your pre-processing code, sometimes you can go ahead and plan ahead of time. So like the pre-processing code, you're going to need that. But obviously sometimes there may be things that you just as a matter of time, as a matter of going through the project over time, you split off later on. Those you can't necessarily plan ahead, but yeah, things like that you can go and plan ahead. Does that answer the question? Thanks.
Do you have any examples of any patterns you've used for storing larger model files separate from the actual package?
Sometimes like S3 on AWS, because you can enable versioning on the bucket, and then in the link that you use to reference the bucket, you can specify which version of the object in S3 you use. But I'm sure there are other options. Don't just use AWS. Yeah, absolutely. Yes?
Do you always use English or format for a
Not always. So for example, like if you make use of like Gensum for topic modeling, they have like a specific format called like memory mapping and stuff like that. It depends on which framework I'm using and which one they recommend. Yeah. Yes.
You were saying you should split that the widget model and model files and model API. Like what should be lived in the model project just besides?
Oh, so in the model package, it should be just the model and just enough code to get it into the environment. Because all the code to actually use it should go in the model API. And the reason is that so whenever you want to send it out, so like let's say you refit the model, all you have to worry about is updating the model package. Or if you make changes to how the model is used, all you have to do is worry about the model API package.
Just like in the helper method package, just
I mean, it depends on how you're structuring your project. Again, I mean, this is why, especially at the end, I specify like it'd be great if we as a community started talking about this more and developing best practices and started talking about how we are doing things at maybe at our companies or in our projects, because this is something that I found useful. But you may find situations where you might want to do that. Yeah. Anything else? Okay. Yes.
So, we talked about setting like what version numbers. I'm wondering about like the N1s. If newest version is 1.2, I know that works. Can we set that as nice, or should I do like? Well, I assume it's not going to break until 2, even though I don't know yet. Should I go up to 2, or
So are you talking about updating or from the developer side of things?
when I'm creating a package, I'm like, the requirement is this package version 1.
Oh yeah. So yeah, that's where especially when it comes to this use case, it gets kind of sticky because especially whenever let's say, so real quick, the question was how should you handle the version number in the requirements, right? So that's where it gets kind of sticky. So when it comes to subpackages that are just code, they're not a model. Then you can use like just sort of the general approach that you might use where you specify only a specific major version, right? Because generally if you're following the recommended Python versioning scheme, the semantic versioning, all other version numbers except for the major should not break the API. Only the major version number can break the API. And so yeah, you can follow that. But I mean, of course, whenever you're specifying like maybe the model file, that's where you kind of have to go with your own thing, and also like depending on how hardcore you are about it needs to be reproducible in such and such way. You may be even more restricted. You may depending on how you approach even how you approach versioning that. You may be using semantic versioning. You may specify only a specific minor version, right? So that's something you have to kind of play with and make sure you have it well documented. Yeah. Any other questions?